Okay, so we're gonna prove Pythagorean theorem, but this time by right triangle similarity. So basically the idea is that you have a right triangle, so here's any right triangle. And what we know by right triangle similarity is that if I take this point and I draw an altitude from that point going down, what I've constructed here now are three similar triangles, and we use this fact to prove Pythagorean theorem. So basically the original right triangle had that this side was A, this side is B, and then this whole side is C, and I'm going to label this capital C, this capital B, and then this capital A. This side length is lowercase c, this side length is lowercase a, this side, and then that side is lowercase b. Okay, now, with that being said, let's label these sides a little bit further. Let's call this length whatever it is. We don't know what it is, but let's just call it x. And then let's call this length, again, we don't know what it is. Let's call it y. Okay, and we'll call this point D, capital D, right there, that point where the altitude meets the side BA. And what's very useful, I find, is that we actually label these angles. So we know that these three triangles are similar. We should know that these three triangles are similar. Triangle BDC, and I'm not saying this in the right order, triangle BDC is similar to the original big triangle, and then it's similar to triangle, I don't know, CAD. Maybe that's in the right order. Okay, whatever, but it doesn't matter. We could see the right order by going like this, putting this as a single tick. That would mean that then this here, how do I get out of this? Uh-oh. Oh, that's cool. I don't want to do it though. Okay. Okay, we see that this will be a double right here, right? A double tick, so to speak. And if I have something like that, what's or this will be a single tick, this will be a double tick, and again, sorry, if these triangles are all similar, then this one would have to be the double because they share that single right here, right? And then that would force this one to being the single over here. Okay, and we should convince ourselves of this. Play this game, see why this makes sense, right? Like, convince yourself that if I have a right triangle like this, right, and I put just labeling the angles, right, as a single tick, a double tick, and a right angle, right, and then I have another triangle over here that I know is similar. Here's the right angle. This single tick they share, so then that forces this one to being the double because the angles must be congruent. So that's why this one's the double right here. Okay, and then if I look at the other triangle over here on the other side, right, they share this double tick, the right angle right here, and then that means that that one's the single, this one's the single right here. And with this, with the angles labeled, it's much more easy to come up with the correct proportion that you need in order to do this. So I like to just sit here and just make this chart, and I'm going to need to make two charts probably, so I'll make another chart right here. And then I'll just have it where I'm going to erase this so I have space for my algebra that I need to get done. And what I have here is that I never want to include the altitude CD. I never want the altitude CD. So I just have to be careful with coming up with this relation. But I'm pretty sure that I want to use triangle 1 and then triangle 2. Now, what is triangle 1? Triangle 1, I'm going to call this green triangle over here on the left. Okay, so triangle 1 is the green triangle on the left. And then triangle 2, I'm going to call this orangish triangle on the big orangish triangle, triangle ABCD. Okay, just to make this easier. Now, in triangle 1, I want to go, let's say, opposite the right angle. So right angle here. And I want to go opposite the right angle. And if you look, opposite the right angle is a length of A. Over opposite the right angle in the big triangle, we should see is opposite the right angle in the big triangle, we should see is this entire side C. So it's A over C will be equal to whatever I put over here. And again, I don't want to include I don't want to include this altitude. So with that in our minds, right, I want to remember that this is x right here, this length, this pink length. Okay, this is x, this length right here. And opposite the double, right, so double tick, double angle, let's call it whatever you want to say, is gonna be x opposite in the first triangle. Yeah, so look at this now pink triangle. Opposite that double one is gonna be that side x over. And then now I gotta go opposite the double in the big triangle. And if you go opposite the double in the big triangle, you should see that you get side A. And that gives me a nice proportion here, because now I have A over C is equal to x over A. I cross multiply, I get a squared equals c times x. And that's the first equation that I care about. The next equation I want to say is that I want to deal with triangle 3, let's say, and triangle 2. Okay, and it doesn't matter if I put triangle 2 up here, you know, or triangle 3 and I reverse the 2. And it wouldn't matter if I flip these two, right? There's a lot of ways to get this correct, and there's ways to get it wrong. One of the ways you can get it wrong is if you ever involve this altitude. So really just keep in mind to avoid using that altitude at any point in this. And now you kind of want to orientate yourself around B, okay? And you want to think, okay, well, B is what in triangle 3? So let's call triangle 3, let's say, is this triangle over here. So this is triangle 3, this green triangle that I'm outlining. And if we say that this is the right angle, okay, opposite the right angle is B over, and then opposite the right angle in triangle 2 is again just C, right, equals, okay, and I gotta pick an angle again, but this time I don't want to pick the double angle in this third triangle, because then that would give me the altitude. So I don't want to use the double tick like I did in the last one. I'm going to use a single tick. And I'm going to call it whatever, single angle, just for short. Single angle opposite in this one is y over the single angle in the big triangle. So in the big triangle is this one. Opposite that is b. And I get this proportion. So then now I get b over c is equal to y over b. I cross multiply, I get b squared is equal to cy. And from here I'm done. Because now I see that a squared plus b squared must for sure be equal to cx plus cy. But then I have that I can factor out the c, and I get x plus y here. And then c times x plus y. If we look, this length was x. So if we look at the original, if I draw the original triangle again, because now everything is all convoluted, this here is x, and this here was y, and the whole thing was c. So x plus y is just equal to c. So this is c times c, and I get c squared. And I've shown that a squared plus b squared equals c squared with this argument here. And I'm done.